Hello, Professor and everyone. Today we're going through with our final project presentation. So our final project is LightControl, and these are the contents that we will be covering today. For the problem that we're trying to solve is, for example, there's people with mobility challenges that they have to use wheelchairs to move from place to place. So it is hard for them to even control the light. So what if we have the system that can control those lights by just using the hand gesture to turn it on or turn it off? And in some scenarios like hospitals, kitchens, or labs, like touching surfaces, it is like hygiene risk. So to avoid the manually touching those, we can implement the system that just use the hand gesture and to control all that. So what our solution is LightControl that let you control the RGB LED lighting with the hand gesture. For the component, we have the ESP32 cam that can detect our gesture over Wi-Fi with the Python server. And we also use media pipe as our data set to detect the hand gesture, and we map it to the lighting mode and send it to the HTTP command to ESP controller, which update those data into our NeoPixel ring and also displayed in the LCD.
And here is our component required. So we have like ESP32 camera for recording live stream of our hand gesture. After that, we also have LCD that can display the data, the color status, and we also have audio center that can custom the light. For example, if that when it's like sunny, our NeoPixel ring will be turned off automatically. And we also have ESP32 controller that can control our NeoPixel ring as well as the LCD and audio as well. Besides that, we also have the software required. For example, we use MediaPath for the data set that we can detect our hands. Besides that, we have OpenCV that can ensure that they can analyze the video from the camera or the live stream, and we also use Arduino IDE, and we use Visual Studio Code Python to code of our hardware as well. And next, let my friend explain about the system architecture and flow.
Now for the system architecture, we gonna take first the system gonna start at ESP32 cam, which act as the eye of the whole system. As this camera over here is the microcontroller with a camera built-in module. And one on its power up, it will be connected to the Wi-Fi and ran a lightweight HTTP server to capture the video in the format of MJPEG, which known as motion JPEG, over the local network. And any device over the same Wi-Fi network can connect to the stream URL, and it will send the frame from 15 to 30 frames per second into the Python server, and the camera does no AI processing at all, as the only job it's doing is to capture the broadcast video. And now on to the Python server over here. Yeah, the Python server has three main functions. The first function is that it reads the frame from ESP cam using OpenCV and handle all the HTTP decoding automatically. And second function is each frame will be passed through MediaPipe, which is a pre-trained AI model from Google. MediaPipe detects the hand and returns 21 landmarks out of our hand joint. And last but not least, the third function, which is our own Python logic, will read those 21 landmarks and apply simple geometry for each of the four fingers. If the fingertip is higher on the screen than the middle joint, the joint that finger is counted as extend. But since the thumb finger is quite different from the other finger, it will be count horizontally instead, since it will be extend sideways. And now on to the ESP controller over here, which when the Python server has confirmed that it will send an HTTP request to the ESP controller, and the controller itself has its own HTTP web server on port 80. When the request arrives, it read the mode parameter and apply to according to the mode that is according to the command it got from the Python server. And last but not least, the LDR sensor. So the LDR sensor here acts as an intelligent auto brightness feature power, which it will be connected into the divider circuit of GPIO 34 on the ESP32, and every 5 seconds the ESP32 read an analog value between 0 and 4095, where 0 mean complete darkness and 4095 mean very bright. This reading is mapped to the brightness level we have here, which the dark room, the normal, and the sunny day. And after all of that, it will send and the data to the neo pixel and to the LCD to display, and also activate the neo pixel. And onto the demonstration.
Okay, we're gonna run our code now. The camera display, so we can demonstrate with our gesture. So if we do this, it will turn it in light color, white, and one finger is for red, two finger is for green, and three finger like this, blue. And we also have the call sign, which is the rainbow, and it will display rainbow like this. And we can also turn it off. Yes. Now let's try with our LDR sensor. So if we want to turn the light on, this one have to detect the darkness. So I will do like this. As you can see, it will display the light here. And it also show in the LCD display as well. So as this one, we want to make it automate. Like if there's darkness, it would display the light turn on. But then it would detect the ambient light, which is the light. So the LED will turn off. Thank you.